Okay, so in today's lesson, we're going to learn how to balance equations. To balance an equation, they are going to follow the law of conservation of mass. Where matter is neither created or destroyed, it simply rearranges. All right, so the mass in equals the mass out. Now, when we balance, we are going to have some rules that I like to follow. Okay, so we want to work left to right. We want to balance polyatomic ions as a single unit when we can. Now, this is not something that we can always do, but if we're able to, we want to balance the polyatomic ions as a single unit. We're going to save hydrogen and oxygen for last. And finally, I'm going to put this in all caps, check your work. With some exclamations, check your work. All right, so let's start with an example. Now we're going to start to balance this first example. We're going to balance it with a particle diagram. And once we do some particle diagram balancing, we'll go back and I'm going to show you another way to balance. All right, but I want to start with the particle diagram because it gives us a good visual representation. The left side of the arrow, we call these the reactants. And a reactant is what goes into the reaction, what I start with. The right side of the arrow, these are my products. The products are what are created, what's being made. So reactants make products. Therefore, this arrow sign is making something, and we call that a yield, okay? So the reactants yield products. So let's start with a particle diagram, and I'm going to draw SO2. And I'm going to draw oxygen, and I made the S a shaded circle and the oxygen unshaded. This is O2, so there's two oxygens there. And now I have an SO3. So 1 sulfur and 3 oxygens. All right, so if mass in equals mass out, I have to have the same number of sulfurs on the reactant side as I do products. And I have to have the same number of oxygens on the reactant side as I do the product side. So what do I notice here? I notice I have 1 sulfur on each side. So that's good. I have 1, 2, 3, 4 oxygens on the left, and I have 1, 2, 3 oxygens on the right. So I have more oxygens as a reactant than I do a product. So I have to add a product. Now I cannot just add a single oxygen here because this is a compound, SO3. So I have to add an entire another compound because we're not breaking up the SO3. It's a compound. It stays as is. Now, when I add another sulfur trioxide, what does that do? That now means I have 2 sulfurs. And as the reactant, I only had 1 sulfur. So I have to add an entire another sulfur dioxide. Again, you can't change the compound. We're not changing the compound here. If you add something, you have to add the entire compound. So now let's look at my work. I have 2 sulfurs for the reactants and the products, and I have 1, 2, 3, 4, 5, 6 oxygens. 1, 2, 3, 4, 5, 6 oxygens. So what does that tell me? That tells me I have 2 moles of sulfur dioxide. So I'm going to put a 2 as a coefficient in front. I have 1 oxygen, so we're going to leave that blank. In math, when there's no value, it's understood to be 1. And I have 1, 2 sulfur dioxide, so I'm going to put a coefficient of 2 there. All right, let's do us another example. CH4 plus O2 yields CO plus H2O. So when I draw my particle diagram, all right, I'm going to draw CH4. I'm making the carbon unshaded and the hydrogen, the carbon shaded and the hydrogens unshaded. And I'm going to draw my oxygen here. I'm just going to put a line through each oxygen to denote that's an oxygen. All right, so carbon monoxide, my carbon was shaded, and my oxygen is the line. And now I have an oxygen here, which is the circle with the line, and my hydrogens were unshaded, H2. So here's my particle diagram for each one of these. All right, and what do I notice here? I notice I have 1 carbon on each side. I have 1, 2, 3, 4 hydrogens and 2 hydrogens. And then my oxygens, I have 2 oxygens as reactants and 1, 2 as the product. So my hydrogens are not balancing here. Now my rules, I'm working left to right. I'm save oxygen for last, but oxygen already balances. I have to now balance my hydrogens. I have more hydrogens as reactants than I do as products. So I have to add another product, and that's going to be the water. I have to add an entire compound, H2O. Now, what does that do? My oxygens were balanced, but now they are no longer balanced. I have 1, 2, 3 oxygens as a product, and I have 2 as the reactants. So I have to come back in here, and I have to add in an additional oxygen. So now I have 4 total oxygens as a reactant, and I have 1, 2, 3 as a product. So ultimately here, we have to just keep kind of working together here. All right, and it's a trial and error type process. What if I add an O? All right, if I add an O, that's going to balance my oxygens. So here we go. But when I add that, my oxygens work, but what did I do? I now have 1 additional carbon, where over here, so I have 2 carbons total, whereas a reactant I only have 1. So I'm going to have to add another carbon monoxide. So drawing with particle diagrams and balancing is kind of an art, all right? And we just kind of work back and forth till we get it to work. So now what do I have? Now I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And on my product side, I have 1, 2, 3, 4. I need an additional 4 hydrogens because I have 8 as a reactant and 4 as a product. So I'm going to have to add 2 more waters. And when I add 2 more waters, that now how many oxygens? I have 1, 2, 3, 4, 5, 6 oxygens. And on the reactant side, I have 2, 4. I need an additional oxygen. So this now balances. So at the end of the day here, drawing with a particle diagram is good to give us a visual of what's happening, but it can get a little bit tricky. All right, I have 2 CH4s. I have 1, 2, 3 oxygens. I have 2 COs, and I have 1, 2, 3, 4 waters. So let's figure out a better way to balance. And we're going to come back up here, and I'm going to rewrite the original equation that we did. All right. I have a coefficient in front. This coefficient is for the sulfur and the oxygen. I have 1 sulfur in SO2. SO2 has 1 sulfur. 1 times 2 is 2 sulfurs, and we see in our particle diagram I do have 2. How many oxygens do I have in SO2? 2. 2 times 2 is 4, and we see my particle diagram does have 1, 2, 3, 4 oxygens. So the coefficient goes to the entire thing. So what I've got here, when I look at this particular equation, I have 4 total oxygens as a reactant and 3 as a product. So I'm simply going to try and get to this 3. If I put a 2 in front, it gives me an even number of oxygens. 2 times 1 sulfur is 2, and 2 times 3 oxygens is 3. So I now have 2 sulfur, so I have to put a coefficient in front. That means I have 1 sulfur times 2 is 2. 2 times 2 is 4 oxygens, plus an additional 2 is 6. And 3 times 2 is 6. So sometimes students like to write out their particular things. We started with 1 sulfur. We had 4 oxygens total. We had 1 sulfur and 3 oxygens, but when we put the 2 in front, 2 times 1 becomes 2, and 2 times 3 became 6. And when we put the 2 in front over here, 2 times 1 sulfur became 2, and 2 times 2 is 4, plus 2 is 6, so we can see that we balance. Let's do one more practice problem. All right, and this one is going to be with a polyatomic ion. And we're going to balance this one without using our particle diagrams, just like we did in the practice problem above. Now, what do I notice here? I notice I have a polyatomic ion. So I'm going to balance this polyatomic ion as a whole. All right, I'm going to balance it as a whole because it appears on both sides. So I have a hydrogen, I have a sulfate, I have sodium, and I have chlorine. So hydrogen, sulfate, 2 minus, sodium, and chlorine. How many hydrogens do I have? 2. How many sulfates? Notice my parenthesis, there's only 1. I have 1 sodium, and I have 1 chlorine. I'm going to count over here. I have 1 hydrogen, I have 1 chlorine, I have 2 sodiums, and again, only 1 sulfate. So what is different here? My hydrogens and my sodium. So if I'm working left to right, all right, I'm working left to right, but hydrogen, my rule was save hydrogen and oxygen for last. So I'm going to go ahead and balance this sodium. I have 2 sodiums as a product, so I need 2 sodiums as reactants. So if I put a 2 in front of the sodium here, there was 1, 2 times 1 is 2. Now, if I put a 2 in front of the sodium chloride, I had 1 chlorine, but again, 2 times 1 is 2. This coefficient goes to the entire compound. So what do I notice? My hydrogens and my chlorines don't balance, but check it. If I put a 2 in front of my HCl, 2 times 1 hydrogen is 2, and 2 times 1 chlorine is 2. So I now ultimately have balanced. So when we have a polyatomic ion, we balance them as a whole if possible. We don't include these, once we balance this sulfate, these oxygens are included in the polyatomic ion, all right? So we would not have to rebalance them again.